In example 5, I have 11 different situations listed out, okay, 11 different word problems. We are not going to solve them yet. We will actually solve these problems later in this lesson. But for right now, what I want you to do is what the directions say. Read each problem and decide whether it should be solved using the compound interest formula or the future value of an annuity formula. Okay, so before you continue watching this video, I want you to try this on your own. You need to read through all 11 problems carefully and figure out or take a guess at which formula should be used in each situation. Is it a compound interest formula or is it the future value of an annuity formula? Okay. Before I pause to let you do that, I want to show you, okay, and I'm going to actually go through all 11 of these, okay? All 11, okay, I'm going to go through them one by one, and I'm going to underline, okay? So like in part A, I see the phrase compounded daily. Part B, compounded quarterly. Part C, compounded semi-annually. Part D, compounded weekly, okay? And I could keep going and doing this on the next page, okay? So you are seeing this phrase in every single problem. Part E has compounded semi-annually, okay? Part F has compounded annually. Part G, compounded daily. Part H, where is it? Compounded monthly, okay? You are seeing this phrase in every single problem. All right, so two more. So on J, let's see, compounded quarterly. Part K, compounded monthly. Okay, that phrase is in all 11 problems. Okay, meaning do not see that phrase and say, oh, it has the word compounded. It's compound interest. Not how it works. Okay, in all 11 problems, you are saving money. I think the exception of one might have like a loan or something, but it still works. So the question is, how are you saving the money? That's how you should make your decision, not based off of this phrase at all. Okay. How are you saving your money? Is it a one-time deposit or are you making regular deposits? If it is a one-time deposit, then it is compound interest. If you are saving money and you are making regular deposits, then it's the future value of an annuity formula that you're going to use. Okay, so like I said, before returning to this video, you need to read through each of these carefully and decide what you think should be used in each case. Okay, and then go ahead and pause your video and you may come back and I will go through each one and we will discuss which formula should be used, and then later in the lesson, we'll actually work each one out using the correct formula. All right, so let's go through each one. Hopefully you've had to look at each one, time to look at each one. Okay, so part A. If each day your fairy godmother put $1 into a savings account at 8.37% compounded daily, how much would the account be worth when you are 65 years old? Okay, so you're lucky here you have some fairy godmother who is saving money for you. Okay, the key here is that the fairy godmother puts $1 into the savings account each day. Okay, it says if each day your fairy godmother put $1 into the savings account. Okay, so these are regular deposits of $1 each. Okay, regular deposits makes it future value of an annuity. Okay, part B. How much should Tom set aside now at 7.9% compounded quarterly in order to purchase a $33,000 motorboat in 5 years? Okay, So the way you read this, okay, you get the illusion here that Tom is taking one lump sum and saving it, putting it in the bank right now, and then letting that money grow through interest over a 5-year period so that he can come back after the 5 years and have $33,000 for his motorboat. Okay, so it is a one-time deposit here that makes this compound interest. Okay, all right. Part C. A person with $14,000 is trying to decide whether to purchase a car now or to invest the money at 6.5% compounded semi-annually and then buy a more expensive car. How much will be available for the purchase of a car at the end of 3 years? Okay, this is a situation you might be able to identify with. Okay, so you're trying to figure out, this person's trying to figure out if they're going to take their $14,000 and go buy the car now, or wait some time, wait 3 years, and try to save the $14,000 and try to build up interest off of it so that he has, a little bit more money to buy a slightly more expensive car. Okay, so this question is asking you, how much money would he have if he decided to save up for the car instead of purchasing it right now. Okay, so this is a compound interest problem, because if he were to save up for the car, he would be depositing the $14,000 into his savings account, that one lump sum, and then letting that accrue interest, and then coming back at the end of 3 years and figuring out how much money he has at the end of 3 years so he can buy a slightly more expensive car. One-time deposit makes it compound interest. Okay. Part D, find the total amount due on a loan of $17,500 at 8.5% for 6 years, 9 months if the interest is compounded weekly. How much of this value is interest? Okay, so this is a question that is not set in a saving money context. This is actually a loan, okay? And we've discussed already that you can kind of look at loans and saving money in a similar fashion, okay? So again, look, when you think about making a loan, okay, the loan is made for $17,500. That money is borrowed at one time, okay? So you're borrowing this lump sum of $17,500, and then you're going to pay it back after 6 years and 9 months. And so that lump sum will earn, interest that you'll have to pay on the loan, okay? So if you can think of it from the perspective that you're borrowing this one lump sum of money, that makes it compound interest. Okay. All right. So next set of questions. All right. So for part E, let's go up here. All right. Tim and Jessica have set up a Texas 529 plan in order to have $120,000 in 15 years for their children's college education. How much should be paid semi-annually into an account paying 6.8% compounded semi-annually to reach their goal? Okay, so Tim and Jessica are saving up for their children's education. This Texas 529 plan is an actual thing, okay? They want to accumulate $120,000 in 15 years. So the key here, how much should they pay semi-annually? Semi-annually means twice a year. So they're trying to figure out how much money should they put in every 6 months in order, so that the money would grow through their regular deposits and through the interest to accumulate the $120,000, okay, after 15 years. So they're going to be making regular deposits twice a year, which is every 6 months. So that makes this future value of an annuity because it's regular deposits. Okay. All right. F. In a suburb, housing costs have been increasing at 5.2% per year, compounded annually for the past 8 years. A house worth $260,000 now would have had what value 8 years ago? Okay. Another problem where we're not saving money here. This is actually an inflation problem. Inflation, remember, probably a very good example of inflation is gasoline. Years ago, okay, many years ago, you could get a gallon of gas for like cents, okay? And now we know it's, $2 or more per gallon, okay? So over time, the same item, its value has changed, how much it's worth, okay? So it's the same thing here with this house. The house is worth $260,000 now, but 8 years ago, the way you read this problem, it says housing costs have been increasing. So right now it's worth $260,000, but 8 years ago, since the housing prices have been increasing, 8 years ago, it would have been worth less. Okay. So we're trying to figure out how much the house would have been worth in the past, 8 years ago. Okay. So this is going to be a compound interest problem. Inflation problems are going to be compound interest problems because you're trying to figure out that past value of the house, that one lump sum that house was worth 8 years ago. It has grown over time to become $260,000. That's its worth right now. Okay. So there's no kind of regular deposit going on here. So that makes this a compound interest problem. Okay, so remember what I said. If it's an inflation problem, it's going to be compound interest. Okay. All right. G, how long will it take money to triple if it is invested at 5% compounded daily? Okay. The weird thing about this problem is you don't have any actual dollars involved. Okay. You're just taking some sum of money and it's asking how long is it going to take to triple. Okay. So for example, okay, if you had $100 and you put it in your account, you're trying to figure out how long it takes to triple or to become $300. Okay. You could pick anything here. How long will it take $1,000 to turn into $3,000? Okay, so the dollar amount is not important here. That's why it's not included. The key here is you are taking this one lump sum. There is no mention of regular deposits, and you're trying to figure out how long it's going to take that one lump sum to triple in value. Okay, so again, a compound interest problem. All right, H. You and your new spouse bring home $1,500 each month after taxes and other payroll deductions. By living frugally, you intend to live on just one paycheck and save the other in a bond fund yielding 7.86% compounded monthly. How long will it take to have enough for a 20% down payment on a $165,000 condo in the city? Okay, so what's going on here? You and your spouse each bring home $1,500 for your paycheck, and you are going to save one of those paychecks. Okay, so you're saving $1,500 and you get paid every month. Okay, so you're using that one paycheck, you're putting it away every month to save up for your down payment. Okay, so you are making a regular deposit. Every month you are depositing $1,500 into your savings account. Okay, so this is going to be future value of an annuity because you have regular deposits. All right, 3 more. What is the final balance of a retirement account earning 5% interest compounded weekly if $40 is deposited at the end of every week for 35 years? And how much of this final balance is interest? Okay. The key here, you are saving for your retirement account, and the key is that you're depositing $40 at the end of every week. Okay, so that's regular deposits, future value of an annuity. Okay. All right. J, a married couple has $15,000 towards the purchase of a house. For the house that the couple wants to buy, a down payment of $20,000 is required. How long will the money have to be invested at 7% compounded quarterly to grow to $20,000? Okay, so this is a similar kind of situation as H, where you're saving for a down payment on a house, but it's a little bit different here. In this problem, you already have $15,000 and you're going to invest that money, that lump sum, and save it at 7% interest. And you're trying to figure out how long you have to wait for that one lump sum to grow to $20,000. Okay, so that $15,000 is a one-time lump sum deposit. So this is a compound interest problem. Okay, last problem, K. Suppose you want to buy a new car and you decide to save up for the car instead of taking out a loan. What amount should you deposit at the end of each month for 3 years in a savings account earning 4.5% interest compounded monthly to accumulate the $18,000 needed to buy the new car? All right, again, how often are you saving money? How often are you making your deposits? Okay, so key phrase here, what amount should you deposit at the end of each month? Okay, so you're making deposits into your savings account at the end of each month. Regular deposits, that makes this future value of an annuity. Okay, so that's how you tell the difference in situations between these two formulas. Okay, so again, I cannot emphasize enough. Let me find my formula sheet. Okay, for these problems, okay, these two formulas, okay, you are saving money. That's when you use these two formulas, when you're saving money. And the difference between the two is how often you are making a deposit. Okay, if it's a one-time deposit, it's compound interest, use this formula. If it's regular deposits that you're making, you're going to use this formula. Okay, so we will actually, in going through the rest of this lesson, we will work, I think, all of these using the appropriate formula and come up with actual answers for these problems.